Chapter 4, number 8. In the circuit of figure 4.34, determine the current label I with the assistance of nodal analysis techniques. This is the given circuit, and we need to find this current. To solve that, to find I, our nodal equations are 5 is equal to B1 over 1 plus B1 minus B2 over 5. That's our first equation. The second equation is negative 4 is equal to B2 over 2 plus B2 minus B1 over 5. To find B1 and B2, we need to use Cramer's rule. So B1 is equal to 3.375 volts and V2 is equal to negative 4.75 volts. The formula to get the current is V1 minus B2 over 5. We substitute the values. So 3.375 volts minus 4.75 volts divided by 5 is equal to 1.625 amperes.
Chapter 4, number 13. Using the bottom node as reference, determine the voltage across the 5 ohm resistor in the circuit of figure 4.39 and calculate the power dissipated by 7 ohm resistor. So we will use here the nodal analysis. So our nodal equations are, first equation would be 8 plus 4 is equals to V1 minus V3 over 3 ohms. Then plus V1 V minus V2 over 3 ohms. Second equation would be negative 4 and equals to V2 over 5 ohms plus V2 minus V1 over 3 ohms plus V2 minus V3 over 1 ohm. Then last equation would be negative 5 V3 minus V1 over 3 ohms plus V3 minus V2 over 1 ohm plus V3 over 7 ohms. And solving these three equations, we would get V1 as 26.73 volts, then V2 8.833 volts, and then lastly V3 8.633 volts. Then the voltage across 5 ohms is equals to V2, so it is 8.833 volts, and the power dissipated by the resistor of 7 ohm, first we would know its voltage. As we can see, its voltage across is equals to V3, so using Ohm's law, and the power formula would be V squared over R, and it's V3 squared over divided by 7, and it is equals to 10.65 watts.
Chapter 4, number 23. Determine the voltage labeled V in the circuit of figure 4.49. So the solution for this problem is that we first select the central node as the reference node. We then name the leftmost node as V1, the top node as V2, the far right node as V3, and the bottom node as V4. So looking at the circuit, by inspection, we know that V1 is 5 volts. We then form a supernode from nodes 3 and 4, then proceed the appropriate KCL equations given. We have two equations, which is negative 1 is equals to V2 over 2 plus V2 minus V3 over 10. And the second equation, which is 5, is equals to V3 minus V2 over 10, V3 over 20, plus V4 minus V1 over 12. After that, we need the KVL equation that relates nodes 3 and 4, which is V4 minus V3 is equals to 10. Solving for that, we obtain V2, which is V is equals to 1.731 volts. So the final answer is 1.731 volts.
Number 47. Through careful application of the super mesh technique, obtain values for all three mesh current as labeled in figure 4.72. This is its solution. By inspection, I1 is equals to 5 ampere. Then, I3 minus I1 is equals to Vx over 3. But Vx is equals to 13 I3. Hence, I3 is equals to negative 1.5 ampere. In the remaining mesh current, negative 13 I1 plus 36 I2 minus 11 I3 is equals to 0. So the answer is I2 is equals to 1.347 ampere.